Our machine doesn't just know how long our tools are or exactly where our part is on the table. We have to tell it these things. Now, our tool offsets store this information for our tools, and our work offsets store this information for our parts. If we have a probing system on our machine, we will use it to set up our offsets, both tool and work. Without a probing system, we will use a digital height setter to set our tool offsets, and an edge finder or 3D sensor to set our work offsets. We are going to use our machine table as our Z-axis reference point for both our tool and our work offsets because it is constant. A certain part might not always be there to set our tools on. Even our vise might get pulled from the machine at some point as our setup changes. But our table is always there. No, really, our table is always there. It's not going anywhere. This digital height setter can be calibrated to light up and read 0 when our tool is exactly 2 inches above our table. Or, with a button push, it can be calibrated for metric mode with an exact height of 50 millimeters from our surface. Now we will load up our tool, jog it down onto our setter until it reads 0, and then press the tool offset measure button while our tool offset is highlighted. Tool 1, offset 1. Now the control doesn't know that we are using a height setter, so we need to go in and subtract its height each time it is used. We could subtract our setter height from either our length geometry column or our length wear column. Now I prefer to enter this shift for our tool setter thickness into our wear column so I can see it later and know that I have not forgotten this step. This setter is 2 inches tall, so we will subtract 2 inches from our length wear column. Our combined tool offset is the distance from our machine Z0 to our table for this tool. We'll repeat this for all of our tools. Jog tool until setter reads 0, highlight tool offset row that matches our tool number, press tool offset measure, subtract for our height setter, and repeat for all the tools for this job. Our control now knows the lengths of all of our tools, but we need to let it know where our part is. When our part was programmed in our CAM system, a feature was chosen to serve as a 0 for our part, usually the center and top of our stock, or a part corner, or any other feature. Now, on our machine, we will use an edge finder or a 3D sensor to set our X and Y axis work offsets to match our CAM system. For our part Z-axis work offset, we will use the distance from our tool touch-off location, which is our machine table in this case, and our part Z-axis 0, which is the top of our stock for this part. We will enter this distance as our part work offset for each part. When manually setting tools, we could just use a piece of paper, but this isn't accurate. Each piece of paper will have a different drag to it and a different thickness. Beyond this, some short tools cannot even reach the table directly to be set with paper. We could use almost any object with a known height to set our tool lengths, but if we want to improve our accuracy and cut down on our setup times, we will want to grab a height setter when setting up mills manually.